Hi, welcome back to Missing Chemistry. This is Lewis dot structure lesson number 2. All right, let's look at PO4, which is like a phosphate ion. So let's go P. All right, P is in group 15. So that means that there are 5 valence electrons around P. Pretty snarly, huh? Okay, let's look at oxygen. Oxygen's in group 16. Greater than 1 again. Now give me 6 valence. All right, let's figure out how many valence electrons we have available in this particular compound. So we go P is 1 times 5 electrons, and O is 4 times 6 electrons. So now, this gives me 5 electrons. This gives me 24 electrons. Oh, it's -3. That means we're going to add 3 electrons, which is going to give me a total of 32 electrons. So whatever structure we draw, it has to have 32 electrons. So we know that P has the most docking force, the single dots. So that's going to be our core atoms. Put P in the middle, and we're going to put O around. The first thing we need to do is connect these to the O. Just like this. Then we have to give all the O's their octets, because all the wraparound atoms have to have an octet. There are some exceptions, of course. It's certainly not going to happen. So far, so good. Now, is this the best possible structure? Now, you have to start thinking about things like that. We're going to use something called formal charge. So we go, the formal charge equals the valence electrons minus the non-bonding electrons minus the bonding electron pairs. Okay? Seems pretty simple. So the ideal is to come up with where the charge of the particular compound is. So let's look at the formal charge here. So the formal charge of the phosphorus. So phosphorus came in with 5 valence electrons. We got that from over here. Okay? And so non-bonding electrons. Well, all the phosphorus are bonded. So we have 0, and bonding pairs gives us, there are 4 bonding pairs. 1, 2, 3, 4. So we have 4 bonding pairs. Right? That's going to give me a grand total of. Let's look at our oxygens. So the formal charge of oxygen would be 6 valence electrons coming in minus non-bonding electrons, they're all bonded, minus our bonding pairs. We have 4. So that gives me plus 2 there. You know what? This is not the best possible structure, because these things need to be either be zeroed out or at least give us a total. Okay, so now let's take a look at this. So what are we going to do? We're going to change things. We're going to redraw the structure, because this is not the best possible structure. So let's go ahead and erase everything. Well, I didn't like the way that turned out. So what are we going to do? Well, what we have to do is we have to take another pair of electrons off of one of these oxygens and put it on the phosphorus. Can you do that? Oh, absolutely. So watch this. We're going to take this one, for example. We could use any of the other ones if we wanted to. That's what's going to be cool about this lesson. So we're going to put this here. And we're going to put this here, just like that. All right, now let's do the formal charges again. So the formal charge of phosphorus this time, phosphorus comes in with 5 valence electrons, non-bonding electrons, they're all bonded, and we have 5 bonding pairs this time. 1, 2, 3, 4, and 5, right? So that looks good, okay? That 0 is important to have. Let's look at the formal charge of these oxygens. Now we're actually going to have to do 2 different ones. We'll call the first one O1, and that's going to be this one right here. We'll call this one O1 right there. And so what we got is we got oxygen coming in with 6 valence electrons. Non-bonding electrons, they're all bonding pairs. Actually, non-bonding electrons, we got 2, 4, 6. And bonding pairs, we got 1. So that's 6 minus 6 minus 1. That gives me a -1. Oh, interesting. And we have 3 of those, right? We have one like that, one like this, and one like that. I wonder what's going to happen next. So let's look at the formal charge of O2. We're going to call this one O2. So oxygen comes in with 6 valence electrons. Okay, non-bonding electrons, there are 4 of them. Okay, and how many bonding pairs? We got 1, 2 bonding pairs. So that's going to give me 0. Oh, so this is going to be -1 times 3, which will give me -3. Okay, so this structure is the best possible structure. So now, let me go ahead and erase some stuff here. Get rid of this. So now we know we're at least in the right ballpark. But there's going to be another small complication to this. I'm going to show you that in just a moment. Okay? So let me go ahead and get rid of this. The question now is, why does it have to be that particular oxygen? We know it's this oxygen, but why can't it be this oxygen? Or could it be this oxygen? Or could it be that oxygen? And the answer is yes, it can be. So what we have is we have something called a resonating structure. So we're going to have to recognize that. Okay? So let me go ahead and erase those check marks and get that done. There. So that structure is correct. But there's another possibility. Why can't it be this? So let's draw our P. There are O's around. Just like that. And this one's going to be okay, like the other one. In this case, we're going to have our double bond there. That's the second possibility. The third possibility would be this. In this case, we're going to put the double bond right there. And if you'll notice that all these structures have 2 electrons. Pretty cool, huh? And there's one other possibility. And it'll be this one. Everything that I've drawn is the best possible structure. I know, it's crazy. It's just snarky. This structure is called a resonating structure, which means that there's more than one possibility on where those double bonds can be. We have like a double bond and single bond kind of combination, usually have a resonating structure. So now we have one more thing we need to do. We have to put a radical around this. And then we have to put the -3 charge right above it. Well, that's it for this lesson, guys. I probably watched this 2 or 3 times. You be snarly, and I'll see you back here at Musin Chemistry!